Okay, so we're just going to go through a couple of examples of factorizing trinomials, and we're going to do it using a slightly quicker method than what we've learned in class. So, not looking at the squares method. Alright, so this is our example. We've got y squared minus 2y minus 15. So the trick to doing these is, well, they are obviously a trinomial, and we can tell that because we have three terms. One's a squared term, one's a term with just a y, and one's a term on its own. Okay, so that's generally how we can tell. We always tend to look for a common factor first, and then look for a difference of two squares. And then our third one is usually a trinomial. Okay, so first in the brackets on the outsides, we always put the factors of this term here. So the the factors of y squared. So that'll be y and y. And on the inside, these two, will go the factors of negative 15. So we take the sign with it, so we're looking for the factors of negative 15. And what you're aiming to do is you're aiming to have those factors multiply by the y's and then add to get negative 2. So how to think about your factors of negative 15. You can do it in your head if you like, or you can list them. That's fine. So you've got negative 5 and 3, 5 and negative 3, 15, negative 15 and 1, and 15 and negative 1. Okay, so they're all our factors of 15. And really, when you think about it, some of them are quite obvious. So, for example, with this one, negative 15 and 1 are never going to add together to get negative 2. Okay, so whichever pair of these factors can multiply by y and then add together to get negative 2 will be the factors that we choose. And when we look at them, we can see that it's negative 5 and 3, because negative 5 add 3 would give you negative 2. So I can put them into the bracket. With these kind of ones, it doesn't matter which order I put them in. So that's it. Done. So we've got y minus 5 and y add 3. And a quick way of checking with these kind of questions, and it'll make more sense when you're doing ones with a non-linear or non-unitary coefficient for y squared, is that when you multiply the two outsides, you'll get positive 3y, and when you multiply the two insides, you get negative 5y. And these two terms should add together to get your negative 2, and they do. So we'll do one more example of this type, and then we will go on to non-unitary coefficient ones. So let's say, for example, c squared minus 10c plus 16. Okay, so double brackets. With c squared, it's easy. Our factors are just c and c, and then our factors of positive 16. Now in this case, we can see that they add together to get a negative. So positive factors are never going to add together to get a negative, so we may as well not bother writing them down. So we'll just write down all our negative factors of 16. So that's negative 4 times negative 4, and negative 8 times negative 2, and negative 16 times negative 1. And we think about which factor pair of these will add to get negative 10, and we can see that that will be negative 8 and negative 2. So c take away 8, and c take away 2. And then you can do your check method. Check the outsides, they'll give you negative 2c. Multiply the insides, they'll give you negative 8c. And together, that makes negative 10c. Okay. Hopefully that is those ones cleared up. And then we're going to move on to the non-unitary ones. Okay, so non-unitary. Excuse my writing. So non-unitary just means you've got a number in front of the x squared. Okay, so not just your x squared plus bx plus c, but you've got an ax squared plus bx plus c. So I'm going to do an example. Let's say 2x squared plus 5x plus 3. Alright, this time we know it's a trinomial again. I'm going to do double brackets. on the outside, you're going to put in the factors of 2x squared. And what's nice about 2x squared is that 2 is a prime number, so it's only got one pair of factors, and that's got to be 2x and x. Okay, we write down our factors of 3 as usual, 3 and 1. We're not going to bother going with the negatives because we know they have to add to get 5. Okay, and our factors of 3 and 1, 3 is prime, so it's just, sorry, our factors of 3 is just 3 and 1 because 3 is prime. So now this time, one of the factors is going to multiply by the 2x, and the other factor is going to multiply by the x, and then they're going to add together to get the 5x here. Okay, so the one that I'm going to multiply by the 2x, I'm going to put out here on the outside. And the one that I multiply by the x goes on the inside, because it's outsides plus insides. It should give me this 5x here. Right, in this case, if I put 3 here, that would become 6x. And 1x, which would give me 7x, which doesn't work. So I should put the 1 here, and the 3 there. Be plus 1 plus 3. So that would give me 2x and 3x, which adds together to get 5x. So that's it. Right, we're going to do a slightly more difficult one because I know that one's quite easy because it was prime. So let's try one that's not prime. So let's say 6y squared. Now, the nice thing about these is that very rarely are the two numbers, how to describe it, the first number and the first term and the last term very rarely have lots of factors. Usually one of them will be prime to make the question more straightforward for you. For example, in this one's got some factors, but this one does not. So you won't be at it for ages. And it does involve a little bit of trial and error. So this time, 2 and 1, it's just, those are our factors. But for 6y squared, that's got some factors. 6y, y, 3y, and 2y. And you don't bother with negative factors ever for these outside ones. Okay, so in this case, you have to think, again, that 2 and 1 are going to go on the out, in the insides, I should say. And in this case now you're thinking about factors of 6y squared, where 1 is going to multiply by the 2, and 1 is going to multiply by the 1, and then they're going to add together to get 7. Hopefully you can see it. So for example, if I use this one, 6 times 2 would be 12, and 1 times y would be 1y, so that would be 13, so that won't work. You can try it the other way around. But you'll still get 2 and 6, which would be 8, which doesn't work. So you can see here that it's this pair. Okay, so 2 times 3 would give you 6, plus 2 would be 8, so that doesn't work. So let's try it the other way. 2 times 2 would be 4, plus 3 gives you this. So I'm going to put the 2y here and the 3y there. So when I multiply those two, I get 4y. And I multiply these two, I get 3y. And together, they add to get my middle term, which is 7y. Alright, maybe one more, and then we should be okay. So let's go with one that's got factors for both, so the most difficult type. So 4c squared plus 12c actually, no, I won't use that one because that one you can just take out. Oh, no, you can't. Sorry. Oh, let's go again. Sorry. 4c squared plus 12c. Now, I know that these ones tend to be positive examples. They're just the ones I have with me just now. It's the same kind of idea with the negatives. Alright, so this time I've got 9, which is 3 and 3, or 9 and 1. And I've got 4c squared, which is either 2c and 2c, or 4c and 1c. So this time I can't put anything in there because I've got lots of factors, well, not lots, but some factors for both. So I have to really think about it. Now I'm adding to get 12, so I'm looking at these factors here and I'm like, what could I multiply by what that'll add up to get 12? So I need to kind of make something that gets kind of big, I suppose. So when I look here, I think, well, 9 times 4 would be 36. It's going to get too big, and 1 is 37. I could go the other way around, so 4 times 1 is 4, and the 9 would give me 13, so that won't work. 3 times 2 is 6, and 3 times 2 is 6. Well, 6 to 6 gives me 12, so that sounds like my answer. So if I put in my 3 and my 3, and I put in my 2c and my 2c, if I check my outsides, that'll give me 6c, and this will give me 6c on the insides, and that gives me 12c. Alright, one last one, and I'll do it with some negatives, in case you're wondering about the negatives. So let's go with 12w squared minus 11w, take away 5. So I'll put my 12w squared, I've gone in the opposite way this time, that doesn't matter, and my negative 5. Well, negative 5 is negative 5 and 1, or 5 and negative 1, so that's a nice prime number. Here we got 12w and w, 4w and 3w, so lots of factors of 12 here, 2w and 6w. You know it's trinomial, so we got our double brackets. At least we can put in 5 and 1. We're not really sure about signs yet, so we'll just leave that blank for now. So one's going to multiply by the 5 and the other by the 1, and then they're going to add to get negative 11. Okay, so let's have a think. 6 times 5 would be 30, too big. Okay, 2 times 5 is 10, and 6 times 1 is 6. It's going to give you 16. We did it negative, we just get 4. Let's try here. 4 times 5 is 20, and then 3, take away 3, that won't work. Let's try it the other way around. 3 times 5 is 15, take away 4. Right, okay, that's getting us to 11, so I think I'm about signs now. So I got myself a pair. And hold on a moment, I won't circle that one just yet. And I've got my 4w and my 3w. Now, what was I thinking? I was thinking that 3 times 5 is 15, and the 4 times 1 is 4. So I'm multiplying 3w by 5, and I'm multiplying the 4w by 1. So I want to get negative 11, so that would have to be negative 15 plus 4 would give me negative 11. So the one I've chosen is the negative 5 and 1, so it's this pair here. Okay, so see there, that involved a little bit of trial and error on my part. And that can be the case sometimes. And sometimes you might fill it in and realize you're wrong and have to go back and redo it, but that's perfectly fine. Okay, and that's it. Factorize there, adding to get negative 11. I hope this has helped.